Welcome back to Talk Tensors. Today we're going to be doing a deep dive into a paper called CRPO, Confidence Reward Driven Preference Optimization for Machine Translation.
Sounds like a mouthful.
Yeah. It's a bit of a mouthful, but the concept is really interesting. It's all about making machine translation smarter and more efficient. It really tackles a key challenge in machine translation,
Right.
which is how do you pick the best training data?
Yeah, and this is something that anyone who works with large language models thinks about all the time.
Right.
How do you actually pick good training data? You can't just throw more data at the problem and
Yeah.
hope it gets better.
Right. It's not just about quantity, it's about quality.
Exactly. And this paper tackles that head on.
Okay, so let's talk about some of the existing methods for choosing training data. One that comes to mind is RLHF reinforcement, learning from human feedback.
Yeah, so RLHF is, it's a pretty common approach, but it can be really expensive
Oh, really?
because you're basically having humans evaluate and score different translations,
That makes sense.
which, that takes time and it costs money.
Yeah, and then there's DPO, direct preference optimization, which tries to make that process a little bit more efficient.
Right, DPO is all about learning from human rankings of different translations.
But it still relies on having that high-quality preference data, right?
Yeah, exactly. If the data is biased or inconsistent, it can really mess things up.
Okay, so where does CRPO fit into all of this?
So CRPO kind of takes inspiration from both RLHF and DPO,
Okay.
but it adds this really clever twist. So it uses two main things to decide which training data to use.
Okay.
One is a reward score.
Okay, like we see in RLHF.
Exactly. And the other is the model's own confidence in its translation.
Oh, the model's confidence? You mean like it knows how well it's doing?
In a way, yeah. So the model assigns a confidence score to each translation it comes up with.
Interesting.
Basically saying, hey, I'm pretty sure about this one, or I'm not so sure about this one.
That's fascinating.
And CRPO combines that confidence score with the reward score from before and uses that to figure out which parts the model's struggling with the most.
So it's not just looking at whether the translation's right or wrong.
Right.
It's also factoring in how sure the model is about its own answer.
Exactly. And this is where things get really interesting. Instead of just training on the stuff the model already knows,
Okay.
CRPO focuses specifically on the examples where the model is uncertain.
Even if the translation isn't terrible.
Exactly. It's kind of like a teacher who sees a student struggling with a specific concept
Yeah.
and gives them extra practice on that.
That's a great analogy.
So it's all about targeting the areas where the model needs the most help.
And did the researchers actually test this out on different types of language models?
They did. They tested it on decoder-only LLMs, which are often used in chatbots,
Yeah.
and encoder-decoder models, which are more common in traditional machine translation systems.
And how did it perform?
Well, they found that CRPO consistently did better than other data selection methods on 10 different translation directions.
10. That's impressive. Did they happen to visualize how CRPO was picking the data?
Yeah.
I think it's really cool to see it zeroing in on those tough examples.
Actually, yeah, they did include a visualization in the paper.
Oh.
And you can really see how CRPO prioritizes the data points where the model is uncertain,
So it's really picking out those challenging examples.
even if the translations themselves aren't that bad.
That's amazing. It really brings the concept to life. This could be a real game changer for machine translation. I mean, making these models more accurate and efficient than ever before.
Yeah, absolutely. And I think this has implications beyond just translation. It really shows how important smart data selection is in all kinds of machine learning.
Right. It's not just about throwing tons of data at a problem.
Exactly.
It's about understanding what your model needs to actually learn.
Right. Like it's the difference between cramming for a test and actually understanding the material.
Yeah.
CRPO is like that tutor who helps you figure out what you need to study.
So to recap, why is this paper so significant?
Well, it introduces this new way of training machine translation models,
Right.
one that uses the model's own confidence to optimize data selection.
And by focusing on the model's weaknesses,
Right.
it allows for faster learning and better results.
Yeah, exactly.
Yeah.
Which could lead to more efficient and accurate translation systems in the future.
Awesome. So we've covered the basics and the history of data selection methods and the core concepts of CRPO.
Mm-hmm.
Now we like to take things a step further here at Talk Tensors.
Right.
In our novel notion segment, we like to think about those what-if questions.
Those big questions.
Yeah, those big questions that researchers are grappling with.
Yeah.
And today we're asking, what if we could use this confidence-based approach for other machine learning tasks, like speech synthesis?
Now, that's an interesting thought.
Yeah, so let's dive into that right after a quick message from our sponsors.
Sounds good. Welcome back to Talk Tensors. So before the break, we were talking about CRPO and how it could change the game for machine translation. Now let's think about how this idea of using confidence could be applied to something totally different, speech synthesis.
Yeah, for those just tuning in, we're in our novel notion segment where we take a concept from one area and see if we can apply it to another. And today we're asking, could something like CRPO help us create more natural sounding synthetic speech?
Imagine if instead of just giving a speech synthesis model a ton of audio data, we could figure out which specific sounds or phrases it struggles with and really focus the training on those areas.
So it's like having a vocal coach who knows exactly which notes a singer needs to work on.
Yeah, exactly. Instead of just learning from everything and it'd be able to zero in on its weaknesses.
But how would we actually do that? How would we apply CRPO to speech synthesis? I mean, it seems like a big jump from translating text to generating human-like speech.
It is a big jump, but the main idea is still the same. We're using the model's own confidence to guide its learning. So let's say we're training a model to read audiobooks. As it's generating speech, we could have a system that analyzes its output and picks out the words or phrases that sound a bit off.
So basically, we're trying to figure out how confident the model is in its own pronunciation. But how do you even measure something like naturalness in speech? That seems pretty subjective.
That's a great question, and it's definitely one of the biggest challenges here. We might need to use a few different techniques, maybe analyzing the acoustic properties of the speech, comparing it to human speech patterns, even getting feedback from human listeners.
So we'd have people actually listen to the synthesized speech and tell us which parts sound weird.
Right, exactly.
That sounds pretty complex, especially if you're working with a huge data set.
Yeah, it'd be a big task, but think about the possibilities. It'd be like having millions of vocal coaches all working together to make the model sound more human.
That's wild. I mean, right now, virtual assistants still sound a bit robotic, especially when they're trying to express emotions or subtle inflections. If we could train models to understand and improve those nuances, it would be a game changer for how we interact with technology.
Exactly, and think about accessibility chabs. People with visual impairments could listen to all sorts of content in a way that's engaging and emotionally rich.
We could have audiobooks narrated by synthetic voices that sound so real you'd forget it's not a person. Or imagine a virtual assistant that could read a bedtime story with the same warmth and expression as a human storyteller.
Of course, there are definitely technical hurdles to overcome. We need to make sure the feedback we're getting is reliable and accurate, and we need to figure out how to incorporate this confidence-based approach into existing models.
It sounds like a really challenging but exciting area of research. This novel notion really pushes the boundaries of what we can do with machine learning.
It does, and it all goes back to that core idea from the CRPO paper, that a model's confidence can be a powerful tool for guiding its learning and helping it do things we never thought possible.
This whole conversation has really emphasized something important. It's not just about the models themselves, it's about how we train them. By understanding data selection and using the power of model confidence, we can take things to a whole new level.
Well said. And who knows, maybe one of our listeners will be inspired by these ideas and actually make these novel notions a reality.
That would be amazing. But for now, that's all the time we have for today's deep dive into CRPO and the incredible possibilities it opens up.
As always, we encourage you to check out the full paper linked in the show notes and really dig into the technical details. And if you have any thoughts or novel notions of your own, we'd love to hear them. Share them with us on social media.
We love hearing from our listeners. Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible with machine learning. It's pretty amazing to think about how much speech synthesis could change. But as we wrap up our deep dive into CRPO, I want to kind of step back and look at the big picture here.
Yeah, I think this paper has really shown us how important it is to be smart about the data we use to train these models. It's not just about brute force, it's about having a strategy.
It's like we're moving from big data to smart data. And CRPO is a perfect example of how we can use a model's own self-awareness, like its confidence in its abilities, to make that happen.
And what's really cool is that this whole idea of model confidence could go way beyond just translation and speech synthesis. What if we could use this for things like medical diagnoses or financial forecasting?
That's a really interesting thought. If we could teach models to recognize when they're not sure about something It could make those predictions more accurate and reliable. I mean, that could potentially save lives
Yeah.
or prevent financial disasters.
Exactly. Instead of just blindly trusting a model, we could use its confidence level to tell us how reliable it is. That could totally change how we use machine learning in tons of different areas.
It's almost like giving these models a sense of intuition, like helping them to understand when things are uncertain, not just crunching numbers.
Yeah, and that's what makes this research so groundbreaking. It's not just about making things a little bit better, it's about changing how we think about machine learning and what it can do.
Well, I'm super excited to see where this all goes. CRPO might be about machine translation, but it's really opened up a whole new way of thinking about how we train and interact with AI.
Totally. And who knows, maybe one of our listeners will be inspired by these ideas and make some amazing discoveries of their own.
That would be awesome. But for now, that's all the time we have for this episode of Talk Tensors. We hope you enjoyed this deep dive into CRPO and all the possibilities it presents.
And as always, make sure to check out the full paper. We've linked it in the show notes if you want to dig into the technical details. And if you have any thoughts or novel notions of your own, let us know. Share them with us on social media.
We love hearing from you. Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible with machine learning.